This is the Atlantic Canada Solar Summit podcast series, brought to you by Solar Nova Scotia. Here we spotlight a few of the summit exhibitors, speakers, and attendees, from busting solar myths with Sergey Syrvachev to exploring cultural bridges and education with Randy Headley, and even diving into battery tech with Ed Neggs. Let's go. Welcome, Sergey. It's great to have you today.
Yeah, thanks for having me.
No problem. So you're with eSTORAGE. I'm looking at your badge. So tell me a little bit about your company and what you're doing.
Yeah, thank you. I am a product manager in eSTORAGE, and I mostly focus on inverter technologies. And like our company, we're a subsidiary of Canadian Solar, so it's a large brand doing a lot of solar. But at the same time, we have like this vertical integration, so we go below, and not only solar, but we also work with energy storages. There was already announcement that we'll build a factory for cells in the United States, and also we work with different vendors for inverters, how to integrate everything together.
So do you do a lot of commercial work or residential work?
Like eSTORAGE, it's mostly utility scale. So our Soul Bank product, you can see it all over there. It's like a 5 megawatt hour system, liquid cooled. All the generation had smaller capacity. And we also have like on the Canadian Solar brand, it's more like residential and commercial industrial. They have like Q-Bank. So we have like different elements in this big puzzle.
So I understand that you're going to be presenting today at the summit. So tell us a little bit about the topic and what you hope to get across.
Yes, I will be talking about regional inertia issues. It's quite interesting topic. Unfortunately, it's difficult. So it's much more about electrical engineering. So people become really dull about this. So I will try to at least somehow entertain them. But generally, inertia, it's a new issue. Like it's arose maybe like a couple of years ago. As soon as we'll get more and more IBR inside our grid. And I will be talking about projects we done in Nova Scotia and doing now in Nova Scotia with grid forming converters, and also just general concept. I want to make this presentation as much technical as possible to give better understanding, because like knowledge sharing is very important now on the market.
Well, you were talking to someone earlier about how technical this topic can be, and it really needs to be kind of, reduced down to like a grade 2 level. Mm-hmm. So tell us a little bit about those challenges.
Yeah, exactly. It's there are a lot of work that actually already was done to trying to reduce, let's say, this topic to make it easier to understand, because a lot of ideas, they are not like we're learning them when we're in childhood, for example. You just need to find the right examples, how to illustrate them, because electrical power in all the cases is something invisible. Like only if you put your fingers in some electrical socket, you will find out that there is actually electric current. So it's not visible. So you need to do assumptions and show in the same way as you see everywhere around yourself. So just try to make this and then just jokes and whatever to keep people entertained, because it's really can be difficult.
What are you hoping to get out of today's summit? Are you attending some sessions yourself?
Yes, I have my schedule. So I found this summit quite interesting, and there are some interesting topics. And to be honest, I want to keep in touch with people. There are like already see a lot of professionals around. So I just want to know about what's actually happening to keep in touch, because we all work in the same industry. So it's good to work together. It's another challenge.
Working, eh?
Yeah, exactly. Because you need to speak with people and understand what they're capable of, because only together we can actually achieve these like 80% renewables goals.
Well, it's interesting because there's a lot of, you were mentioning earlier, there's a lot of misconceptions that are out there. What are the main ones that you hear in your travels?
Misconception today and tomorrow, they could be different, because technology changes so fast.
Yeah.
like we are lucky that we're not in IT world where, I don't know, ChatGPT can get 1 billion subscribers in a month. So it's a little bit slower. But again, like when I was doing my presentation about grid forming converters, I did really fun exercise. I Googled what's grid forming converters, and I asked ChatGPT what's grid forming converters. When I Googled, it showed me black start functionality. It was coming from DOE, Department of Energy, United States website. So imagine like person Googling grid forming and getting its black star. It's just one function of the whole bunch of functionality. So it's a misconception already. So people will be got confused. And ChatGPT answered me so generic question that I could not actually understand what it means. So yeah.
That's true. And I use ChatGPT almost every day. It's just an amazing tool that's just getting smarter.
Yeah.
Right. So with battery storage and solar, there's a lot of combinations and there. So with battery, storage, as you mentioned there, how is that coming together? What does the future look like there?
It's a bright future. Like nowadays, we see that actually storage and solar, it's the fast growing markets in renewable. And that's actually funny that actually storage now is faster growing compared to solar. So it's the cheapest generation. So we're not talking about incentive that government gives, but nowadays it's already changed. And it's kind of already misconception that solar is booming because of the government. No, it's already on the stage where it's most viable. It's the cheapest source, so everybody will be building it. And they go pretty well because you have a lot of solar generation, free energy. But depending on previous sources of energy, like oil, coal, wood, whatever, they could be stored and transported. Solar, you can't store. You can't ask, okay, God, please make my solar sun shine a little bit more. So you can't do this. You can't suddenly increase generation. And you need ways how to store it. And that's where batteries finally come up, this technology that allows you to store it and do it in affordable way. And that's why together, it's kind of combination. Solar +2, let's say, batteries +2, but together they give you like +6 instead of +4 because the combination is like a double benefit.
Right. Now, you mentioned earlier that it's the utility side that you work in. How big would these storage systems need to be?
Well,
Depends, right?
yeah, it depends. It's as big as you can imagine. It's all depending on grid and so on. Like in Nova Scotia, our projects are like every project is 50 megawatt, 200 megawatt hours. It's for a system, but it's grid forming, so it's a huge project, especially for Nova Scotia.
Right.
But generally, what we see from the market, that projects could be like several gigawatt hours easily. And the most interesting part, that's how it's growing. When I just started, we like 5 years ago, we were talking about like several megawatt hours project. 3 years ago, I was working on 16 megawatt hours project, and it's considered a big one. Next year, it was already 100 megawatt hours, and nowadays we're talking about 1,000 megawatt hours project. So you see, it's kind of doubling, tripling all the way, and it's fun. It's fun because it's new challenges to make 5 megawatt hour project and 1 gigawatt hour project. You can do with the same equipment. You need to optimize your equipment. And because I'm product manager, I need to think about this, how to actually make this product better for like mass big projects.
Right. Well, how much physical space would it take? Like 5 megawatts compared to, 1 gigawatt? Like, are we looking at the size of a house or a size of a warehouse?
Yeah, so 5 megawatt, that's 20 feet containers. So it's 2.5 to 6 meters footprint. We have setbacks from different sides to allow like convention, and you have also fire hazards, so you need to make sure you put them in some distances. When we're coming to gigawatt hours, it's like several 100 square meters, so it's a big place. It's already like football fields filled with batteries, and you can imagine they're really heavy. And when you're talking like in the USA, I work with batteries. How big? People think about like like this AA battery or whatever, and you say, okay, my battery is a little bit bigger. Let's say it's like 100,000 tons of batteries.
Well, what about the security? Like if a utility has this, you've got to protect these areas from vandalism or anything like that. Have you guys thought about that potential happening? It kind of probably needs to be in a certain area.
Yes.
Location is important.
Yes, usually it's in control of EPC company who will actually construct this site. There is fencing, there is lighting, there is protection system. So it's not just standing somewhere in the field because it could be a spot that costs you maybe $500 million. You can imagine that there will be not so issue. And let's be honest, it's high voltage equipment. Let's say high voltage on medium voltage, and on DC it's like 1,000 volts. So if even anybody will try to reach it, it's not safe. You need to have some kind of knowledge of what you are doing. So and even okay, you stole battery. Now you need to sell it. Like you can't sell it like independently. Like before this, I worked with lead acid batteries, and with lead acid batteries on the local market, it's kind of funny stuff that you actually can steal the battery and sell it as secondary, like for recycling, and get money from this. And there was even some kind of lead acid batteries with GPS trackers, because on telecom they install it on every base station, like every big, and thieves, they just quickly go around there, open it, take batteries, and run away because it's remote locations. And so people at telecom operators start to install like GPS models to track them.
So these are lithium-ion batteries,
Yeah.
right? And of course, the cost of lithium is quite, costly these
Mhm.
days. And I know that there's all kinds of new technology coming along, like they're studying sodium ion, a lot of different types. So you guys are probably have
Yeah.
your finger on the pulse with that.
Yeah, what I tell you is we should not look into competition as a, like, let's say, static picture. So you have development. Every technology is developed with some kind of speed. And at the end, finally, will be who is the cheapest, plus who is most, let's say, fire safe, whatever, like other related issues. And if we're talking in a static snapshot, we see that there is like flow batteries, whatever, like sodium batteries you mentioned. But at the same time, the speed of progress development, all LFP batteries or lithium batteries, it's so quick that right now I'm not strong believer of other technologies because these technologies is developed so quick. Like there are a lot of discussions about flow batteries, to be honest, like and it was like a couple years ago. But the thing is that it's going like price reduction of these batteries too slow. Like company can keep in pace with lithium solutions. So and they have the initial, like potential initial long duration energy storages, but at the same time, we can say that there is a huge chance that actually lithium battery will become much cheaper to that time when LDAS will be in such developed stage. Right. So it's just like game who will come to this end first.
Right, and and you were saying that like the size of a football field could be the massive one. Maybe with the technology, it could be a smaller footprint.
Yes, exactly. And it's kind of challenge. It's always about cost and benefits. You can go bigger. To become smaller, you need something more energy efficiency, but there is a limitation in case of materials that you use in the battery. And you can't just make like improvement of power density. So it takes a lot of time. And there are another concern. You make more power dense batteries, so you put more batteries inside the same container because 20-feet container is most like useful size now. And but how will you transport it? Like how you will deliver it? Like it will weigh like 30,000 tons, and your bridges will just collapse. So sea transportation is okay, but last mile with trucks, it's a challenge.
Now, before we leave today, I just want to ask, is there anything else that, you want to get across, in our conversation today?
It was a nice conversation. And I just want to make sure that people listen to this podcast, to other entertainment, because knowledge sharing in this industry is number one priority. And because industry is progressing so fast, we should be the same, let's say, as IT industry, where technology changes rapidly, and you just need to be not just I'm working from 8 to 5, but you should be involved in the discussions happening on the market, and you know all new developments that's happening every day.
Well said, Sergey. Thank you so much for joining me today, and we'll see you throughout the conference throughout the day.
Okay, thank you so much.